Okay, we're on to some geometry, some transformations. G1, 2, 3, and 4 talk about transformations. We're on page 19. Number 1 says translate the figure down 3 units. All you're doing here is taking the edges of this. Okay, so I have 4 corners here. And each of those needs to be translated down 3. So if I take this first corner, go down 3, 1, 2, 3 is the new one. I'm going to make it big when I make the new one. All right, and then the bottom corner here is going to go down 1, 2, 3. Top corner down 1, 2, 3. Bottom corner 1, 2, 3. So the whole thing just got slid down 3 units. Of course, it should be rectangular shaped. Okay, number 2. We're going to rotate this 90 degrees clockwise. So you're going to take your whole paper. I can't do that, but you can. You can take your whole paper and rotate it 90 degrees clockwise and read these coordinates. In fact, I'm going to write that on here. Turn paper 90 degrees clockwise and read new coordinates. So I'm going to take my figure and rotate it 1/4 turn, which is 90 degrees. So your paper, it should look like that. And we're going to read these coordinates of the edges. We're pretending that this goes all the way to the edge there. Okay, so it looks like I have coordinates of, well, the bottom here is just 0, 0. Okay, the next one above that is 0, 3. Again, this is the y-axis, this is the x-axis right now when you're looking at it, right? And the third one is going to be at 1, 3. Once you have your 3 coordinates written down, you can turn your paper back to how it was normally. Because I have my dots there already, that's convenient. Okay, so your paper should be like that, and you're just plotting your dots where mine actually are, at 0, 0. 0, 3, and 1, 3. And that's going to be your new shape. We rotate it 90 degrees clockwise. As you can see, it went 90 degrees that way. Okay, number 3. We're going to reflect this over the y-axis. Be careful. Some people get confused and they do the wrong axis. So I'm going to use a little highlighter just to show you that this is the axis I'm reflecting it over. Okay? So that means every point has to be the same distance on the other side. So if this point, we're just going to pretend that's right on the axis, so it's not going to go anywhere because it didn't go anywhere when it reflects. So that's going to stay the same. So every corner piece, we're going to reflect it. So if we take, and I'll do them in different colors maybe to make it easier to explain. So this green corner, you can see it's 1 away from that yellow line, so it just has to be 1 away on the other side of the yellow line. And this blue dot here, again, we're pretending they're on the corners. It looks like it's, let's see, 1, 2, 3, I counted 4 away from the yellow line, 4 boxes away from the yellow line. So I'm going to go 4 on the other side. That to me is 4 away from the yellow line. Okay, and I'll call this one the black one here. We're going to do this black one. It looks like it's 3 away from the yellow line. So 3 away on the other side would give me the rest of my figure. Connect your dots. And as you can see, it is now a reflection over the y-axis. You guys are pretty good on this stuff. Okay. Translate the figure down 3 units and to the left 4 units. So down 3, left 4. So if I start here, it's going to go down 3. This is my big one, right? Down 1, 2, 3, and left 1, 2, 3, 4. That's my other spot. Okay, if I take this corner, go down 3 and left 4. And the third corner, down 3, left. So my new triangle goes right here. And you don't need those other little dots on the page. That was just for me to show you where I was going. Okay, page 20. More transformations. Are the following 2 figures congruent? Well, congruent means same shape and same size. It has to be the same shape and the same size. Do these 2 look the same? They look the same to me. Same shape, same size. So this answer is yes. Okay. Number 2, describe the transformation from figure A to A prime. It's going from here to here. The only thing we could have done here is to slide it. As you can see, its orientation is the same. It hasn't turned around or got reflected or anything like that. It's facing the same way. So what did we do? Well, let's check a point. Any point will do. If I check this top corner, well, the corresponding keyword, vocabulary word, corresponding point in the other figure would be here, right? Same point in the other picture. What did I do? If I translated it, let's see, it looks like I'm going down, and it looks like I'm going right. It doesn't matter which one you do first, we'll go down. Down 1, 2, 3, 4 to make it even with the other one. Down 4, and right 1, 2, 3, 4. So the transformation would be, let's see, we got to write that down, translation, called a translation when we slide. Down 4, right 4. You could use your little transformation key here like this. So that what did the X do? It got bigger by 4, and the Y also got bigger by 4. You can do that as well, but the words are just fine for me. All right, number 3, describe the transformation from A to A prime. This one looks like we have a couple things that could have been done, since it's a figure that we can't tell if it's been like turned around really, or if it's facing the same direction. So 2 options for this one. One option was that we rotated it 180 degrees, right? If we rotated it 180 degrees, it's still going to be the same shape. You can turn your paper and see that it looks the same. So one option, (180 degrees), meaning 2 turns either way, 2 turns right or 2 turns left, clockwise or counterclockwise. But we could have also translated it, because you can't tell, does this one line up with this one? We don't know for sure. It could. So if we translated it, well, what did we do? We went down 1, 2, 3, 4, and went right 1, 2, 3, 4. That's the same as the last one, right? So either rotated 180 degrees or translated. Got it down 4, right 4. Either one. they were probably going for rotation on that one. Describe the transformation from figure A to figure A prime. So A, this small one, is the original, and A prime is the new one. Sorry, my board's a little off here. So I'm going to erase that just so you can see it again. So let's pick a point, any point on there. And you're going to find the corresponding point on A prime. So if we find a point on A, maybe this one, that corner, find that same corner, the corresponding corner on A prime, it would be this one. All right, let's read the two coordinates. Let's read the two coordinates. We have the first one, A, is, let's see, 2, 1. And that same coordinate on A prime is at 4, 2. Well, what are we doing? Don't forget, this is a dilation, so that means multiply. What do we multiply the top one by to get the next one? It looks like I have to multiply by 2, right? 2 times 2 to get 4, 1 times 2 to get 2. So the dilation factor, remember when things get bigger or smaller, it's a dilation. It's a dilation by a factor of 2. We're still going here. Page 21 is still transformations. We have a triangle with coordinates A, B, C here. It's translated 4 down and 3 to the right. So if we have a triangle, it starts at 0, 0, that's point A. 0, 3 is point B. And oh, this one should not be done on a graph. Let's do this one not on a graph. I apologize. I put this here for another reason. I'll move that for now. Let's just talk about it without the graph. You can do it on a graph, don't get me wrong. But let's do it, since they didn't really give us a graph, we're going to do it algebraically. So 4 units down means that which variable gets changed? Down, up and down controls the y-axis. Okay, and then 3 units to the right would be the x, okay? If you're going down, we're getting smaller, right? We're subtracting. So we're going to subtract a 4 from each y coordinate. And for the 3 units right, that's getting bigger. If you go to the x-axis, going to the right is getting bigger. So we're going to add 3 to the x coordinate. Again, this can be done on a graph. So our new thing is just going to add those things. So 0 plus 3, if I'm adding these two together, I get 3. And the second one, 0 minus 4, is just negative 4. B prime is taking 0 plus 3. Again, I'm right here. 0 plus 3 gives me 3, and this one here, 3 minus 4, is negative 1. And then lastly, C prime, 1 plus 3 is 4, and 1 minus 4 is negative 3. So that's going to be your answer. And yes, you could do it on a graph, but it is good to know both ways. All right, a triangle with coordinates A, B, C here is reflected over the x-axis. Now, the reason why I put this graph here is because I wanted to show you how you know which variable gets changed. If you pick any point, ignore the question for a second, just plot any point on this graph. Okay, how about this one right here? If we're reflecting it over the x-axis, which is this axis, well, it's going to go, if it's 4 above, right, it's going to go 1, 2, 3, 4 below. As you notice, the x variable in there doesn't change, right? The first point is at 3, 1, 2, 3, 4, 3, 4. And the next one is at 3, negative 4. So the variable that changes if it goes over the x-axis is the y. The x still stays a 3, the y just gets changed to the opposite side. Okay? What I want you to write down is this stuff here. If we're going over the x-axis, the x stays the same, and the y changes the sign. Pause the video if you need to. A prime, well, the x stays the same, so it's still 0, and the y changes the sign, but since it's 0, it's still 0. And we'll write it down here so I have room. B prime, x stays the same, 0 stays the same, the y changes its sign. Instead of 3, it's negative 3. And again, I'm reading these from right here. A and B, and then C, C prime, x stays the same, y changes its sign. Instead of a 1, it's a negative 1. And that's all there is to it. Number 3, a triangle with coordinates ABC is rotated 90 degrees counterclockwise. What are the new coordinates? Well, again, for this one, you can definitely graph it. And I suggest if you have confusion and can't remember these algebraic formulas, then just graph it. But if you want to know, we have x, y. When you rotate it 90 degrees counterclockwise, it changes to negative y, comma, x. I'm going to do it the graph way, though, just because I think that's less confusing. So if I take a piece of graph paper, so go get yourself a piece of graph paper for this one. Pause the video if you need to. We're going to draw a triangle at 0, 0, 0, 3, and 1, 1. Okay, that's my triangle. I'm going to label what I have here. This is A, B, and C. Okay, and what you're going to do now is do what it says, rotate it 90 degrees counterclockwise. And when I rotate mine, don't write your y and x on your graph, okay? Because when you rotate it, it's going to be different. I put it on the paper, not on my graph itself. So I'm going to go 90 degrees counterclockwise. That's going this way one time, 1/4 turn. So my new A is going to be, we'll write it here, A prime, looks like it's still at 0, 0. B prime is now going to be at negative 3, 0. And C prime, I'll write it down here so I can fit it, is at negative 1, 1. And that's all they want. You don't need to plot it on the graph, you just need to give them the coordinates. All right, we have another triangle dilated by a factor of 1/2. Dilation 1/2. That means to multiply by 1/2. So if we multiply each thing by 1/2, multiply it by these things, right? 1/2, 1/2, 1/2, 1/2. Well, our A prime, 1/2 of 0 is still 0, and same for the y coordinate there. B prime, 1/2 of 0, still 0. 1/2 of 3, you can do it as a decimal if you'd like. 1/2 of 3 is 1.5. You can use your calculator if you need to. C prime, well, 1/2 of 1 is just 1/2, or 0.5. You can write the fraction of 1/2, or 0.5. And that's it. One more page for this one. I know it's longer. I apologize. We'll try to get through it quickly. Describe the transformation from A to A prime. Well, A to A prime looks like it is a slide. What did we do? Well, take any point and find the corresponding point in the new one and tell me what I did. If I translate it, I slid it down 3, 4, and right 1, 2, 3, 4, 5, 6. So we translated down 4, right 6. If you want to do that in this form, well, the x-coordinate is the right one. The right got bigger by 6, and the down got smaller by 4. And now I just realized that I messed up on the other one. Did you catch that? The one that I showed you before with the down 4 and right 4, the y should have been -4. So I apologize. All right, but anyways, the words are just fine. You can just do the words if you want. Number 2, describe the transformation from figure A to A prime. So you are, it looks like it's turning to me, turning. You could turn either way, but I'm going to go that way for now. So if I'm turning, how many quarter turns is that? How many turns would it take me to do the page if I'm going to get it from one to the next? And now that I'm looking at it, that actually won't work. So let's think about what else we can do. We could do a series of transformations. What if I started with a translation of 4 units right? Let's see. So let's do that. Let's just see where we get. 4 units right. So this point goes to this point. This point goes to this point. And this point goes to this point. So right now we have a triangle. Let me make that line a little bit better. Okay, there we go. My board is a little bit off here. So now it looks like that triangle. So I translated it 4 units to the right. What would be the next step to get it to look like the triangle with A prime? It looks like I need to reflect over the x-axis. So we have a series of transformations. First translate it 4 to the right, and then reflect it over the x-axis. It would flip it over there, and then it would look like that triangle. Okay, number 3, describe the transformation of A to A prime. There's going to be a series of transformations here. We're going to start by translating it 1 unit right and 1 unit up. One right, 1 up. So 1 right and 1 up. That one would go here. This one would go here. And these 2 would go to here. So if we did it that way, then I can rotate it, because now you can see that this edge here, this edge, is 1 away from this axis, whereas this edge is 1 away from this axis. So that will make it nice when I go to rotate it. And I want to rotate it 90 degrees, 1/4 turn, clockwise. All right, and the last one, describe the transformation from figure A to A prime. This time it starts with the bigger one and goes to the smaller one. So if I pick a corner and pick the corresponding corner on A prime and read those coordinates, I'll be able to figure out what I multiplied by. So A, let's forget the negatives. You guys don't like negatives. Let's do the positive coordinates. Let's do the positive ones. A is at, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. We've been bombarded with bells today. It's been a little frustrating. So A is at 4, 4, and A prime, that same spot, is at 1, 1. Again, we have to multiply by something to get from this one to that one. Well, if I have to multiply by 4 to go this way, I'm really dividing by 4, right? But dividing by 4, we should know by now, means to multiply by 1/4. So if I multiply both of these by 1/4, I will get my 1/1. So the dilation of, excuse me, by a factor, I should say, to make it nice. By a factor of 1/4 will get me my new rectangle or square.